Let's begin with auxiliary 1, AUX1. I'm going to move to the top of the sheet of the first problem, and it says the complete top, front, and right side views are given. So all of our views are correct. Using the fold lines to measure, draw the auxiliary view of the inclined surface only. Not the whole object, just the inclined surface. Now, in this case, this is my right side and this is my front view. And we're going to take our measurements from the right side view. We could also have a fold line here, and since we're measuring depth, we could also just as easily have gotten our measurements from the top view. But since we have our grid laid out for measurement, we're going to go from here. The first thing to realize is that the inclined surface, not an oblique surface, but an inclined surface, appears here as an edge view. Over here, I can see the inclined surface foreshortened in the right side view. So all we're going to do, we're going to take our inclined surface, move it out here, and lay it flat and have it true size and shape in the auxiliary view. Since I have my points already located, it makes it very easy to do. I know that it's generally going to have this shape here, and if I were to sketch, I know that it's going to look something like that in the auxiliary view. Let me draw that a little darker. I know it's going to look something like that in the auxiliary view. Now, if you remember, we are going to project perpendicular to the fold line. This fold line and this one are located arbitrarily, but on this sheet of paper, this one is located so that when you draw the auxiliary, you will still be on the sheet of paper and not hanging off. So from the fold line back, it's 2, 1, 2. So for point 1, 1, 2, and I'll label that as point 1. Point 2 from the fold line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's point 2. Point 3 is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Point 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I notice that the line 2, 3 is parallel to the fold line, just like the line 2, 3 here, parallel to the fold line. Point 4, 1, 2, 3, 4, 5 from the fold line, 1, 2, 3, 4, 5. It's down here. 1, 2, 3, 4, 5. Here's point 4. Point 5 from the fold line now, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's point 5. And point 6, 1, 2. Now I have located all of my points. I simply connect the dots, 1 to 2, 2 to 3, 3 to 4, 4 up to 5, over to 6, and close. Now, this is my auxiliary view, and it is true size and shape, which is what I was looking for. Notice that this measurement here, which is foreshortened, has been stretched here, and therefore I'm seeing that measurement, true size, combined with the depth, true size, and I get true size and shape. A couple of other ways to look at it. I am drawing it here, I'm projecting it from here, I'm getting my measurements from here. So it's 1, 2, 3. This is depth, and that's depth. Now let's move up and we'll take a look at another problem. And our instructions are going to tell us that the complete top, front, and left side are given. Label the corners to aid in projecting the points into the auxiliary view. Use the fold lines to measure distances. Draw the auxiliary view of the inclined surface only, not the whole object. Now, I do have a top view, but in this case, I'm getting my measurements from the left side. So I'm just going to move my sheet up, and I'll ignore that top view for a moment. And as I look across here, I can see that as I project over here, my corners match up. The hidden line is the back side of this edge here, and therefore very lightly, just to give you a sense of where it occurs, this is my inclined surface here. This is the notch or the opening. If I move back to the top, I can see that notch or that opening. So my inclined surface goes from here down to here. If I label my points, and the order does not matter, I have 8 points. Looking toward this from this direction, I can see this would be point 1 and then 2. So this would be 1, 2. Looking in this direction, this would be 8, 7. Looking in this direction, 5, 6, and 4, 3. Now all I have to do is project those points out here and connect them. From the fold line over for point 1, it's right there. From the fold line, 1, 2, 3, 4, 5, 6, 7, 8, 9. From the fold line, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is point 2, point 8, and I realize that all of these points don't fall perfectly on the grid. Some of them are closer to the halfway mark, so we get them as close as we can. 5, 6, okay, from the fold line, 1, 2, 3, 4, 5. From the fold line, 1, 2, 3, 4, 5. So here's 6. And I notice that 7 is the same distance as 6. So if I wanted to, I would know that that's point 7. Here's point 4, 1 grid away. And 3 is the same distance back as 2. So I know that 3 is going to be back here. Now, to draw the inclined surface, whoops, we can do better than that. And we can improve that a little bit here. Now, I'm going to slide this down just a little bit, and as you can see, this and this surface and this surface are really the same. It's just the shape from here to here that changes. And what I'm doing, I'm combining this true length, this true length measurement from here to here with, in this case, the depth. If I were to take this drawing, I could have had a fold line here in front of the top view and measured back, and still I would have the very same measurements to combine with the length of that inclined surface. And this, of course, is true size and shape.